Imagine you're inside a digital fortress. You've slipped past the outer walls, but you're just a nobody, a low-level user. Your goal? To get to the throne room, the absolute center of power, where you can do, well, anything. Today, we are cracking the code on how exactly that happens.
Hello and welcome to LM Reads. I'm a researcher who loves to break down fascinating books for you, and today we're pulling back the curtain on the art of digital lockpicking inside the Linux operating system.
Okay, let's just jump right in. The entire game, the whole reason for this, it all comes down to this one sentence. It's all about getting a shell running as the root user. That's the grand prize, that is the keys to the entire kingdom. But what does that actually mean?
Yeah, exactly. What is this root user? Why is it so special? Why is getting its power the absolute end game?
Think of it like this. If your computer was a video game, the root user is the one with God mode turned on. It has the special user ID of 0, and because of that, the system grants it total, absolute, unrestricted access to everything. Every file, every command, every secret. It can create users, it can delete the whole system, it can do anything it wants. So becoming root means becoming all-powerful.
So, to understand how to get that power, first we have to understand the security system that's designed to stop you. And it all boils down to one word: permissions.
At its heart, Linux security is just a giant list of rules. Every single file, every directory has a little tag on it that says who's allowed to look at it, who's allowed to change it, and who's allowed to run it.
And this is how it's all organized. It's pretty straightforward, really. You have 3 simple questions. Can you read, write, or execute a file? And those questions are asked for 3 groups of people. Are you the owner of the file? Are you part of the file's designated group? Or are you just one of the others?
And this is what those rules actually look like when you're on the command line. At first glance, it just seems like a bunch of random letters, right? But it's a code. The first RWX means the owner can read, write, and execute. The next R-X means the group can read and execute, but see that dash? They can't write. And the last R-X means others can do the same. This little string of code, that's the fortress wall. Okay, so we understand the blueprint of the fortress. Now for the fun part. Let's look at how to find the cracks in the wall. This is where the heist really begins.
You know, the simplest way in is often just a dumb mistake. Imagine there's a file that contains the encrypted passwords for every single user, including the all-powerful root user. Now, this file is supposed to be locked down tight, so only root can see it. But what if someone messed up? What if they left the door unlocked?
And that leads us to a classic heist, the case of the readable shadow file. Step 1, the discovery. You find out the etc shadow file, the one with all those secret password hashes, has been misconfigured. Anyone can read it. Step 2, the theft. You just copy the long, scrambled string of text that is root's password. Step 3, the crack. You take that hash offline and use a tool to just hammer it with millions of password guesses a second until you find a match. And finally, step 4, the payoff. You go back to the machine, use the switch user command, type in the password you just cracked, and boom, you're in, you are root.
But, you know, it's not always about finding a file that's been left wide open. Sometimes it's about tricking the programs that already have the keys to the kingdom.
And there are 2 really important ideas here, sudo and SUID. They sound similar, but they're very different. Think of sudo like this. Your boss hands you the keys to their office and says, hey, you can run this one specific program on my computer, then give me the keys back. You have temporary, limited power. But SUID is different. That's like finding a special saw in the workshop that's hardwired to only turn on with the foreman's master key. If you can figure out a way to use that saw to, pick a lock, you are suddenly using the foreman's power for something else entirely. So how does this actually work? Well, an attacker scans the whole system looking for these special SUID programs owned by root. They find one. Maybe it's an old text editor or something. They realize that because this program always runs with root's authority, they can use it to open and edit a file they should never be able to touch. Like the file that controls who all the users are. So they just edit the file, add a new user for themselves, and give that new user root privileges. Game over. These specific tricks are really fascinating, right? But what this book really gets at is something bigger. It's about a very specific way of thinking.
Getting to root isn't about knowing one secret command. It's not a magic trick. It's a process. It is about being a detective, about carefully collecting clues and piecing them together to find a path that nobody else ever saw.
And this is the playbook. It starts with what's called enumeration, basically making a map of everything. What's running, what are the permissions, who's logged in. Then you start looking for weaknesses on that map. You're looking for that one loose thread, that one small flaw. And sometimes the real artistry is chaining multiple tiny little flaws together to build a ladder all the way to the top.
So, after exploring the fortress, the flaws, and this whole mindset, what's the big takeaway from a guide like this?
For me, the verdict is this. This book is way more than just a collection of technical recipes. It's a masterclass in creative, analytical thinking, the kind of thinking that's absolutely essential for anyone who wants to build or break secure systems.
What it really does is train you to look at any system, any set of rules, and ask, what are the hidden assumptions here? Where are the gaps? What happens if I use this tool in a way its creator never ever intended? It's a mindset that's obviously crucial for cybersecurity professionals, but it also gives you this fascinating glimpse into the logic of how things get broken.
All right, let's talk about the art of the digital heist. Today, we're diving deep into Linux privilege escalation. This is all about how a cyber attacker goes from being an unwanted guest in the lobby to suddenly holding the master key to the entire building.
Okay, so picture this. A hacker gets in. They've breached the outer wall, but now they're stuck. They're on the ground floor with a low-level guest pass. They can't get into the server rooms, they can't access the executive files, nothing. Their goal is the penthouse suite, that all-powerful root account. So how do they get there from here?
Well, here's the thing. They're not going to start blasting through steel doors. That's loud, it's messy, and it sets off every alarm. No, the smart attacker looks for mistakes. They search for the digital equivalent of a key left under the doormat, a window that's been left unlocked, or a janitor's closet where the master keys are just hanging on a hook. That, right there, is the heart of privilege escalation. It's not about brute force, it's about being clever and exploiting the weaknesses that are already there.
So, to really get how this all works, we've got to understand where the attacker is starting from. What does their world look like right after they first get in? They begin with what we call a low-privilege shell. This is their first tiny foothold on the system. And honestly, the skyscraper lobby analogy is perfect. You're inside the building, which is a big step for sure, but you can't actually do anything. You can't operate the elevators, you can't get into secure areas. You're just kind of there.
From this point, their objective is crystal clear. It's one thing and one thing only: become the root user. In the world of Linux, root is basically the god of the machine. It's the ultimate super user. If you can get a shell, a command prompt, running as root, you own the entire system. Period. Game over. You can see everything, do everything, change everything.
Okay, so the goal is set. Now, a smart attacker's first move isn't to start attacking wildly. Nope. The first move is to just look around. It is time to case the digital joint.
And this isn't random wandering. It's a methodical process. The first thing they do is check their current identity. Okay, who am I on this system? Usually it's some low-level account like www.data. Then they'll fire up automated scanning tools to map out the system. They'll dig through command history files looking for juicy little secrets like passwords, and they'll just poke around the file system, searching for things that shouldn't be left out in the open.
And what are they looking for exactly? They're looking for clues. Anything that's out of place. We're talking about passwords just sitting in old files, private security keys that were left behind, or critical system files that for some reason anybody can read. They're also hunting for bigger picture issues, like misconfigurations in powerful tools, scheduled tasks they can hijack, or maybe just a really old, vulnerable version of the operating system itself.
This hunt for clues leads us right to the first and honestly one of the most common ways an attacker gets a leg up: exploiting things that were just put in the wrong place.
You see, every Linux system has a few absolutely critical files that act like the master ledger for who's allowed to do what. If an attacker can get their hands on these, it's like finding the building manager's logbook with all the key codes in it. It's a shockingly simple path to a total takeover.
Here's the classic example: a file called Etsy Shadow. This file holds all the user passwords, but they're scrambled or hashed. Now, on a secure system, only the root user is allowed to even look at this file. But what if someone messed up to permissions? If that file is readable by everyone, the attacker can just make a copy of the root user's scrambled password, take it back to their own computer, and then use powerful software to crack it. It's just a matter of time before they have the real password.
Okay, so besides finding stuff that's been left out, Attackers also look for ways to abuse special privileges, things that were set up for a good reason but could be twisted into something dangerous.
Let's talk about something called the SUID bit. It's a special kind of permission. Normally, when you run a program, it runs with your limited permissions. But if a program is owned by root and has this special SUID bit set, it runs with root's power, even if you're the one who ran it. Think of it like this. For one very specific task, your boss gives you their master key. You can open any door, but only for the purpose of that one job.
So, where's the danger? Well, what if that program can be tricked? If an attacker finds a program with this SUID power that's also vulnerable, they can manipulate it into doing something it was never designed for, like, say, opening up a command prompt with full root powers. And just like that temporary master key you were given, it just became a permanent one.
It's a similar story with the sudo command. Its whole purpose is to give a normal user temporary admin powers for very specific tasks. But if it's set up wrong, it can create a massive, gaping security hole. For example, if you let a user run a powerful program like a text editor using sudo, an attacker can almost always find a way to escape from the editor back to a command line that now has full root privileges.
Now, this next technique is really clever. Instead of trying to break down doors or trick the guards, the attacker just hijacks the building's own automated systems to do the work for them. In Linux, these automated systems are called cron jobs. They're just little scripts that are scheduled to run automatically at certain times. Things like nightly backups, system cleanups, you name it. And here's the key. To do their jobs properly, these automated tasks often have to run with root privileges. They're like the system's robotic maintenance crew.
So you can probably see where this is going, right? What happens if the script file for one of these robotic janitors is left unlocked? If an attacker finds a script that's scheduled to be run by root and they have permission to edit that script, it is absolutely game over. They just erase what's in there, pop in their own malicious code, and wait. The next time the schedule ticks over, the system itself will run their code as the all-powerful root user.
But the attacks can get even sneakier than that. Some of these scripts use a wildcard, that little asterisk, to tell a command to run on all the files in a folder. An attacker can abuse this by creating a file with a very carefully crafted malicious name. When the automated script runs and sees that file name, it gets confused. It thinks the name isn't a file, but an extra command to run. It's like a Jedi mind trick on the computer, fooling it into executing the attacker's code.
So, after all the scanning, all the probing, and all the clever exploits, the attacker finally reaches the end of the heist. They've made it.
This right here, this is the prize. User ID, 0. In the Linux universe, that number means one thing and one thing only. You are root. The attacker has successfully climbed the ladder all the way to the top.
They are in the penthouse. They have the master key to every single room. They can read any file, install any software they want, delete any user they want, and, this is the really scary part, they can scrub all the logs and completely cover their tracks. It's total, silent control.
So how in the world do you stop this? Well, you've got to be diligent. It's all about proactive security. You lock your digital doors and windows by enforcing strict file permissions. You hand out those pseudo master keys as little as humanly possible. You regularly check your system for any of those potentially dangerous SUID files. And of course, you always keep your software and your system kernel updated to patch any known holes.
And all this leaves us with one final crucial question to think about. It's so easy to focus all our energy on building a big, strong, reinforced front door for our security. But as we've seen, privilege escalation almost never happens that way. It happens through the forgotten side entrances, the unlocked windows, the misconfigured maintenance hatches. So take a moment and think about your own systems. How many of those little windows have you accidentally left open?
Ultimately, it's a peek into the incredibly complex dance of digital security that kind of powers our whole world. And if this deep dive into the hacker's mindset got you curious, well, then the book has done its job. Let me know in the comments if this makes you want to pick up the book.